Hello everyone, I will present the subject in chemistry engineering on the topic two-stage modeling strategy for industrial fluidized reactor in gas phase ethylene polymerization process. Topic presentation. The first topic introduction and the second topic description of industrial gas phase ethylene polymerization process, and third topic is two-stage modeling strategy for industrial fluidized reactor in gas phase ethylene polymerization process, and final topic implementation of the process strategy. The first topic introduction is a type of polymer offering a wide range of properties such as durability, good chemical and electrical resistance. There are two types, is low density polyethylene and high density polyethylene. Linear low density polyethylene or LDPE is a class of LDPE with short uniform state branching and can be used in a wide variety of applications such as plastic bag, film and packaging. Gas polymerization is one of the advanced technology for the industry production of LDPE. The main advantage of this process is heat transfer and material compared to other polymer manufacturing technology such as polymeric process and solvent. In addition, solvents are not required for the polymerization of gas-based fluidized polymerization. The reactor is a gas phase polymerization process for the production of LDPE. In a type of reactor, the small solid kinetic particles inside the reactor are encapsulated by the gas monomer ethylene. In a production of polymer particles due to its high compact, polymerization mechanism and model are essential in design for optimized industry polymerization process. The second topic, description of industrial gas phase ethylene polymerization process. Gas phase polymerization is a main process in catalytic polymerization to produce LDPE and to remove heat from polymerization. Kinetic use titanium and alkyl aluminum including titanium tetrachloride and deuterium aluminum respectively are fed to the lower part of the fluidized reactor. The import of gas monomer and hydrogen and nitrogen as a modulator for the molecular weight of polymer and co-monomer. 1-butene is used to improve the properties of polymer within the fluidized reactor. Within the catalytic particle which become polymer, the reaction portion of the fluidized reactor has particle and gas phase expansion. The gas released from the fluidized reactor is passed through a compressor and a refrigerant to eliminate the thermal reaction. The third topic, two-stage modeling strategy for industrial fluidized reactor in gas phase ethylene polymerization process. For the third topic, it can be divided into three more topics. 3.1 Kinetic of polymerization reaction for the first state, such as active starting site generation, chain transfer reaction of two hydrogen monomer and transfer to catalyst in conjunction with spontaneous chain transfer and terminating reaction. 3.2 hydrodynamic model and heat transfer to the second state. Dynamic continuity, momentum equation or equilibrium equation, and hydrodynamic energy equation. Reaction start from the bottom up to the top of the feed die bed. The feed die bed is divided into a bed. The first step in at the bottom of feed die bed reactor. 3.3 solution method for hydrodynamic model and heat transfer. Advantage: the employ into enable the simulation of process involving both dispute and actual parameter model. The leg of the feed bed reactor is separated by mean of the difference in each step. Get in using gear show how to combine this line method and solution are technically applied to various chemical process. The final topic: implementation of the proposed strategy. The kinetic of polymerization reaction are calculated in the first step, and the kinetic model with hydrodynamic and heat transfer within the feed are calculated in the second step. Use a series of PDEs. The first step, the monomer with nitrogen and hydrogen are added mixture and introduced into CHCr1 to calculate the kinetic with hydrodynamic and heat transfer of the polymerization reaction hydrodynamic 1. The second step, the gas phase, extending the first layer in path up to CHCr2. In the second layer to allow the gas to pass up to the higher region. The polymerization kinetic for the second layer is then calculated CHCr2 and hydrodynamic 2. Repeat the process until the last layer on top the fluid die bed. The gas outlet stream is recycled to a compressor and chiller respectively. Finally, the polymer product is separated for the polymer separator. The parameter of the inlet of the first state called the flow rate and composition, temperature, pressure, and physical and chemical properties of both gas and solid. Finally, the modeling of intensity feed die bed polymerization. The reactor was showing include internal dynamic behavior. The feed die bed polymerization reactor is not linear due to complex polymerization reaction, heat and mass transfer, multi-phase mechanism, and characteristics. In modeling feed bed polymerization reactor in section intensity, the large amount of bed there is not easy. The complexity should be simplified while still capturing the sky point. Okay, I will like to add the presentation. Thank you very much.